In example 3, we want to determine if the function, which is given by an equation, demonstrates an arithmetic, geometric sequence, or neither one will justify our answer. Well, I want to remind you of some things. So for arithmetic, we would see a sequence that looks something like this. The important thing here is that the n is going to be multiplied by a number. It's actually not going to look exactly like this, but it's going to look something close to that. For geometric, the key here is that we have some value raised to n, or the n minus 1 power. It could be just n, and that'll give us a geometric sequence. You can actually calculate these out too. You could use n as 1 for the first term, n as 2 for the second, and so on. But I think we're going to look here and see if we can reason through this a little bit. So part A sub n is excuse me, 16 plus 3n. Totally looks, well, not totally, but kind of like this. You can also think of this as slope-intercept form. The rate of change is the same every time. In this case, we'd be adding 3 each time. And if you needed to, you could make a list of numbers, but this one is totally arithmetic. The next one looks almost like this one, except a sub 1 is negative 4 and r is negative 3. So this one's geometric. With part C here, this one looks kind of like this here, where that n is being multiplied by a number, and so this will be arithmetic. And you might be thinking to yourself, hey, well, you're multiplying in this case, but it turns out that repeated addition will look like multiplication in the formula, but you're really just adding the same thing. In this case, you'd be adding 200. The same thing goes for geometric sequences. You're multiplying by the same thing each time, and repeated multiplication is really an exponent, so that's why you see that n up in the exponent position like it is here. This one's a sub n is equal to 2n squared. In this case, we're going to have a parabola, and it's going to look something like this if you graphed it. Now, a sequence is not a continuous line, it's separate little parts of it, but this totally isn't either one of them. So there's an exponent here, n has to be raised to the first power, and also the n is not in the exponent position, so it's not either one of these. E is a little tricky, but you can see that exponent position here is, you got an n, and so this one will be geometric. A sub n is equal to 14.5678 over n. In this case, what we have is a sequence that's neither. That n is not being multiplied, it's in the bottom of a denominator, and it's not an exponent. So this one will be neither.